The question the student brought to us has a car A driving east toward an intersection and car B, which has already gone through the intersection heading north. We want to know at what rate the distance between the cars is changing at the instant when car A is 40 miles from the intersection, traveling at 50 miles per hour, and car B is 30 miles from the intersection and traveling at 60 miles per hour. The first issue that us and most people have in determining for these questions is determining the equation we need to tackle the problem. To start, we will draw a diagram with the information given. So we will let X represent the distance between car A and the intersection, and we will let Y represent the distance between car B and the intersection. From here, we can see that we have a right triangle, where the distance between the two cars is the hypotenuse, and This solves the hardest part of the problem as we can use the Pythagorean theorem as our equation for solving.
So we can see that through this diagram that d squared through Pythagorean theorem is equal to x squared plus y squared. We have x equals to 40, we have y equals to 30. From the information given, we can also see that car A is traveling at 50 miles per hour, so the displacement is decreasing. So the derivative of the displacement is equal to negative 50 because it's decreasing. The velocity is negative. And in this case, we have dy over dt, which is 30 miles and traveling at 60 miles per hour away. So it's positive 60. Another piece of information that we can get from this graph is the distance at time t equals 0. So at this time. So we can see Pythagorean theorem, 40 squared plus 30 squared, take the square root of that is 50. So we have d is equal to 50 at this moment. So now we can differentiate this equation over here implicitly. We get 2d dd over dt is equal to 2x dx over dt plus 2y dy over dt. And now we have d, which is 50. We have x, which is 40. We have y, which is 30. dx dt, which is negative 50, and dy dt, which is 60. We just substitute that in, and we will be able to find dd over dt, which is what we want over here. So in conclusion, the hardest part of this question, which is what me and Michael struggled on at first, is actually finding this expression to differentiate. And through this motion picture diagram, we can just do just that.